All right. So let's continue our discussion. Let's say we want to do the naive forecast, right? So as we have discussed in naive forecast, we know that the answer for f plus 1 is nothing but dt, where we said that the forecast for the next period is going to be the demand in the current period, or forecast for today is nothing but demand in the previous period. So we'll apply this particular principle to analyze this. So first I'm going to create example 1, naive approach. So in case in the exam you are given questions based upon these forecasting, try to apply the concepts that we have discussed. That is, we will not ask you the entire procedure to do this particular thing, but we will be expecting you to understand the concept of this, right? So I'm going to use the same concept over here. Okay, right. So how do I do this? Now, when I'm doing this particular thing, look at what we are trying to do. So this is the demand value. This is the actual demand value. Now I am creating forecasted demand from this. Forecasted demand would be, as you would know, ft plus 1 is dt. Now, just for our understanding sake, let me put the values over here. The notation for all of this would be, let's say, d1 would be d2, d3, and so on, right? So these are the values corresponding to this, right? So there are 12 demand values. Now, forecasted demand would also be the same way, right? So this one will be F1, F2, F3, and so on, right? So this will be the values that we have. Now, as we have discussed in the class, the forecasted demand for F1 will be equal to, according to this particular formula, F1 will be equal to D0. But we don't have D0, so we will start with F2 is equal to D1 and so on, right? Because F1 is something equals to D0 and we don't have D0 over here, we are going to start with D1 and we can only forecast F2. So by that logic, what we are going to see is that we are going to start with this particular value C2 over here, and this particular value F3 is going to be D2, right? So because ft plus 1 is equal to dt, by that logic f3 will be equal to d2. So the same logic I have applied over here and I can predict all these values. So according to this particular prediction, the corresponding value of the demand in year 2 of January happens to be 618. Okay. Now we have discussed that the efficacy of any particular forecast can be identified by 3 things. Right? We said one called as MAD, which stands for mean absolute deviation. The other one stands for MSE, which stands for mean squared error. And then MAPE, which stands for mean absolute percentage error. Right? So let's calculate these things and try to see what is the efficacy of this particular forecast that you have calculated. Now, the MAD value, MSE and MAPE values, the formulas for those things are provided in the PowerPoint that is shared with you. If I have not shared that with you, I will share it immediately. Let's calculate that mean absolute deviation. For that, in the class I have created a table which is deviation. The other one is squared deviation, and then we have looked at percentage deviation. So this is what we are going to calculate now as well. So deviation is going to be absolute value of the original demand minus the forecasted demand. Now, why we are taking absolute value is something that we have discussed in the class as well. If we don't take the absolute value when we are averaging out the deviation, it might so happen that the positive and the negative errors might cancel out, which we do not want, and hence we take the absolute value. So this is also like taking only the magnitude but no sign corresponding to the error or deviation. Okay, so this is the deviation. We calculate all of this. Please note that we do not take the deviation for the last one, which is the forecasted demand, because there is no actual demand value over here. Now, mean absolute deviation is nothing but the average of the deviation values. right? Average of the absolute deviation values. And that is why this is calculated as average of these things. Okay, so this one is my mean absolute deviation. How do I calculate the deviation square? Deviation square is nothing but whatever deviation that you have calculated, the square of that is going to be the deviation square, right? Now, this deviation square can also be dragged the same way over here. The value that you are going to get by taking the squared error or deviation square and average of that is what we refer to as the mean squared error. How do I calculate mean squared error? It is an average of all these values, right? Okay, just for the ease of you, what I'm going to do is let me use the formula text so that we can understand what this value is. Okay, so this is going to be the same everywhere, right? So I'm just going to write that average text. This. Okay. Now, this is the squared deviation. For percentage deviation, what we are going to do is we are going to take the deviation, that is the absolute deviation, and we are going to divide this by the actual demand value. So in this particular case, the actual demand value happens to be 438. So this is what I am going to divide. And my percentage deviation for all of this is calculated like this. Now, how do you think we calculate MAPE, which is mean absolute percentage error? The word mean over here is nothing but representing your average value. So just take the average of the previous values. That's about it. This gives you the average value, right? And I can even give you the formula for this. This happens to be this. Now over here, we are getting a percentage error of 13.86. Right, so these are the important values for us. And correspondingly, this particular value is also important because this is our forecast for year 2 January. Right, so this is how we are going to do this. Okay, so we have calculated our mean absolute deviation, mean squared error, and mean absolute percentage error like this. Now we go to the next method, that is simple moving average. Now please note that in the class when we were discussing Marriott-Rooms forecasting, we had multiple pieces of information, and for those reasons what we had done was we had used the forecasted pickup ratio instead of forecasted demand to arrive at the right answer, right? All right, so if you look at it, let's move to the next method, right? The simple moving average method. So in simple moving average, as we have discussed in the previous classes, forecast for the future is merely going to be an average of the past values. So that is dt, dt minus 1, dt minus 2, and so on, right? Now, over here, when we are doing this, we are calculating that we don't have any requirement that we only have to use the previous few values, right? Or previous 2 values, previous 3 values. This is also going to be more like a trial and error method, right? Now, sometimes in the quiz, you might be also asked to only use, let's say, past 3 values, past 4 values. So please make sure that you note how many values are being asked to be calculated. Now, using the data, we will also see how that can be calculated, right? I'm copying and pasting this entire thing into the next one, that is simple moving average. Let's see how this turns out to be when we use the simple moving average. Now we said that FT plus 1 is average of the last 3, right? So I can say, let's say for example, A 3-period simple moving average. What is the meaning of this 3-period simple moving average? A 3-period simple moving average would mean that we are trying to calculate the average of the past 3 periods, right? Past 3 periods. Now, for that, that means ft plus 1 over here in the some 3-period simple moving average would be just the average of the past 3 periods. That's it. There is no other values that are going to be there. Now, if I say that I'm going to use 4-period simple moving average, then the same thing would become, instead of the average of dt minus 1, dt minus 2, I will also include dt minus 3. Okay. Now, just to make our life simpler, I'm going to go with a 3-period simple moving average. You can also try out a 4-period simple moving average like what we have done over here. Now, if you look at it, let's say, for example, I'm talking about 3-period simple moving average. By this particular logic, if we have to calculate F1, F2, F3, and using our D1, D2, D3 values, let me start with F1, right? If I have to calculate F1, just substitute the values. So if I have to calculate F1, as you can see, the formula in here to calculate F1, T happens to be 0, right? So substitute the values over here. So this becomes average D0, D minus 1, and D minus 2. Right? Now we said that we don't have D0, neither do we have D minus 1 and D minus 2. In the same way, if I have to calculate F2, it will become average of, to get F2, substitute T is equal to 1 over here. T is equal to 1 makes this F2, and this will become average of D1, D0, and D minus 1. Right? So this is something, again, I don't have D0, I don't have D minus 1, I have D1, but I don't have these two. Same way, if I have to calculate F3, this will become, instead of D1, it will become D2, D1, and D0. Again, the same issue. I don't have D0, so I cannot calculate this. Now, when I go to F4, I have an average of D3, D2, and D1. If you look at this particular formula, I have D3, D2, and D1, all of them. So I don't have to worry about it. So I'll go ahead and use this particular thing. Now that means I neither have F1, which is over here. I neither have F2, which is over here. I neither have F3. I cannot calculate any of this. Okay. That means the only thing that I can calculate over here is this particular thing, F4, and any value going forward. So for those reasons, what I'm going to do is I'm going to say that all these values are not something that I'm going to calculate, right? So let's take this value. So that means that if I'm not calculating forecasted demand, neither will I have deviation or deviation square or deviation percentage. I'm just going to remove them. Now, how do I calculate F4? If you look at it, it is the average of the previous 3 values, that is B, D3, D2, and D1, right? So I take an average of that. This is a simple moving average, right? So just take an average of that and then simply drag this. Why? Because if you look at this, when I drag this, it is taking C5, C4, and C3, which is nothing but demand of 4th period, demand of 3rd period, and demand of 2nd period. That is what we are getting over here, and so on, right? Now, once I did this particular thing, you can see that all other things automatically got adjusted. Now, in the previous period, I think we have got an MAP of 13.86. Now we are able to achieve an MAP of 12.8, slightly better than the previous case, right? A simple moving average. Now, You could as well try this with a 4-period moving average. Now, what happens in a 4-period moving average? I take the past 4 values. Now, naturally, you will realize that if I have 4-period moving average, then I can only start from F5, not from F4, right? That is something that you can try out. Now, let me try to see how I can calculate, instead of a simple moving average, how can I do a weighted moving average, right? Now, in the weighted moving average, let me first copy all these values over here. Okay, this is the values that we have. Now, in weighted moving average, instead of this particular formula, that is ft plus 1 is equal to average dt minus 1 dt minus 2, we said that the forecast ft plus 1 is going to be w1, or let's start with the dt value, that the previous value. So let's call it as wt dt plus wt minus 1. We put it like this: wt minus 1 dt minus 1 plus wt minus 2 dt minus 2. Now, as you can understand, dt minus 1 dt minus 2 are previous values starting from dt. Its dt is the immediate previous value, dt minus 1 is the previous 1 period previous value to dt, dt minus 2 is 2 periods previous to dt value, and so on, right? So like this, you have all weights, whatever you choose, and divide this entire thing by the weights, wt plus wt minus 1 plus wt minus 2, and so on, right? So this is your ft plus 1 formula. Now, same way, if I have to do this for 3-period moving average, that is 3-period, not any moving average, this is weighted moving average. What I'll do is I'll say that ft plus 1 would be nothing but wt dt plus wt minus 1 dt minus 1 plus, please remember that this is only 3-period, right? So wt minus 2 dt minus 2. This divided by w1 or wt plus, let me be lazy, let me copy this part. Okay, let's take this part, paste it over here, we just this. Instead of just close it over here. So I only use 3-period weights. Now, as you go to 4-period weighted moving average, instead of 3 items over here, in your numerator, you will have 4 items. I'm just trying to make this more exact formula. So this is how you are going to get it. Now, let me show this thing for a 3-period moving average. Now, as we discussed in the class, for a 3-period moving average, I need 3 weights. What are those 3 weights? Over here, let me call them as W1, W2, and W3. So over here, if I have to write this particular formula, as we have seen in the last time as well, whenever you are doing moving average, if I'm calculating 3-period moving average, I can only start from F4. So here also, I am directly starting from F4. It will become W1 D1 plus W2 D2 plus W3 D3 divided by W1 plus W2 plus W3. Okay, this is how I give this particular weights, right? The only thing that you have to remember here is these weights have to be non-negative integers. So let me just give 1, 2, 3 to start with. Okay, these are the weights that I am giving. It could also take 0, and we will see what happens over there, right? Now here, when we looked at this particular calculation, we have taken the average of near simple average of these things. Now we are not going to do this. We are going to take a weighted average. Weighted average formula is over here. Now the best way to do this particular thing is use a sum product, right? You've used this, you've done this a lot, and you are using it for OR, so I'm not going into that. Sum product is merely sum of this or product. Sum product is these values chosen by these values. So D1, D2, D3 multiplied by W1, W2, W3 in that particular order. Okay, divided by the sum of the weights, right? And please note that these weights are not going to change. I'm going to freeze them. You know how to freeze them. You have to use F4. F4 will automatically freeze them. Next, what should I do? As you can see, the denominator is sum of these weights. We take sum of these weights, right? Which you can also directly write it as 1 plus 2 plus 3. And this is how it will take care of it. So now I'm going to use a weighted moving average instead of a simple moving average. Now, as you can see, what has happened, my MAP value, as I moved from Naïve approach 13.86% to 12.8% to weighted moving average is 12.16%. Now, we are seeing that as we move to better methods, we are able to get better output. Now, that's not enough, right? So we said that in weighted moving average, we can also choose the optimal weights so that we can reduce the MAP value. How do I do that? We've discussed that. We have seen even for the exponential smoothing in the classroom, we can use solver for that. Let's try to see this, right? So I'm going to use this solver. Now, please note what is our objective. The objective is to reduce MAP value or minimize MAP value. So I'm going to set that this is my objective. I want to minimize this. What are the values that I need to change? I had chosen 1, 2, 3 values earlier. I will choose these values and I want to change them. And I know that this particular thing again is not going to be a simplex. It's going to be GRG nonlinear because it has weights in the bottom. Now, I don't want to use any other constraints other than this because automatically it will take care of these. So I'm just taking these values and making these variables unconstrained non-negative values. Right? So let me select this and say solve. So this is what this particular solver has identified, that if you use a weight of 2.15 for weight 1 and weight 0 for weight 2 and 1.94 for W3, it happens to give me the best weight that happens to be 11.83. Now, please note that these weights that we have calculated over here or the MAP value that we have calculated over here is not the exact best solution. So Excel also gives you a near optimal solution and it depends upon what weights do you start with. So because I started with 1, 2, 3, it might so happen that when I use 40, 47, 30 or some other values, the solution might be slightly different. So even if you get different answers when you try it out, don't be surprised because it depends upon what is the starting point for this. Now, the background behind this is that it uses something called as a numerical methods, which can only give you a local optima, not a global optima. And that is the reason for this. Not really important for you, but this is the logic behind that. Okay, so this is about the weighted moving average. Okay. Okay, this is about the weighted moving average, right? Now, let's look at the same thing for our exponential smoothing, right? So I copy the same thing. Let me just copy the same thing over there. And let's go ahead with that. Okay. Now, or rather, what I will do is, let me not copy this, or let me copy the Naïve approach part, because I will work with almost everything over here, right? Copy this. And let me name this as example 1 and exponential smoothing. Now, as we know in exponential smoothing, we know that the formula for ft plus 1 is equal to alpha multiplied by dt plus 1 minus alpha, alpha being our smoothing constant ft. So this is a formula which is a very recursive formula. It depends upon the previous forecast, right? And there is only one thing that we have to, there is no multi-period moving average kind of concept over here. There is only one thing that you have to choose, that is your alpha value, right? And we know that the alpha value happens to be between 0 and 1. So to start with, I am going to start with, let's say 0.3. Now over here, what we are going to do is the same way we have looked at the previous case. If you want to calculate f1, f1 happens to be alpha into d0 plus 1 minus alpha into f0. Now, neither do we have d0 nor do we have f0, so I cannot go ahead with that. Now, when I go to f2, alpha, it becomes alpha into d1 plus 1 minus alpha into f1. Now, because we were not able to calculate our f1, because f2 has f1 also over here, by this formula, I cannot calculate f2, and going forward, I cannot calculate anything else as well. And this is what we have discussed in the class 2. Now, what we can do is, to avoid such a situation, we can make sure that we can assume, and this is an assumption that we start with, that f2 works the same way as a naive forecast. Now, if we assume f2 to be equal to d1, then going forward, what we can do is, from f3 just becomes, look at it, 3 just becomes alpha times d2 and 1 minus alpha, sorry, this is 1 minus alpha 2. Now, please note that we have d2, we also have f2, which is calculated from d1 over here. That takes care of this, right? This is also 1, so I'm just making that change. So we'll go with this particular logic. So what I'll do is, and this is what I've done in the class as well, I'll store alpha in a particular value, right? So that whenever I use it, formula appears like that. Now to start with, the first value of the forecasted demand is going to the previous demand, F2 is equal to D1. So we have used that, right? Now here, what I'm going to do is this value, I'm just going to say alpha into D2 happens to be this, plus 1 minus alpha times F2 is over here, so I'm going to use this, right? Now that's it. All I have to do is drag this formula and automatically everything changes. So as you can see over here, this becomes dependent on these values and so on. Now in the class, I said that the best way to get this particular alpha value, which minimizes the MAP, is we can use our solver. And we are going to use the same thing. In the previous case, we had different W values which I had to choose. Here it's only one thing, right? So we will go ahead with that. Just that we know that alpha value lies between 0 and 1. So we will have to probably include a constraint, right? What value am I going to change? I'm going to change alpha. And what is the constraint that I'm going to add? I'm going to add a constraint that alpha value happens to be less than or equal to, alpha value happens to be less than or equal to 1. That's it, right? So we have this, and we are going to ask it to solve that. It says that maybe some kind of an issue. Let's look at that. So we are trying to minimize this. Oh, sorry. I picked up the maximum value, which is minimize. It says solve. So it says that 8.36, it happens to solve this, and it gets 12.51. Now, surprisingly, this value is lower than the MAP value that we got over here, but we cannot do any better than this. So we will have to live with this, right? Seems to be, but it is less than the other two, simple moving average and naive approach. So this is okay. Right, so these are the methods that we use in the time series. When we go into the regression, we had discussed that we have a dependent variable, we have independent variables, and so on, right? Now over here, when we go about regression, let's talk about certain things called as trend and seasonality that we are going to use. Okay, we'll discuss about trend and seasonality and how do we calculate that for a given data. How do we also use regression to solve that particular thing? We'll understand that. Okay, so there are two major concepts in regression, and also these are concepts related to the time series data which is the past data which is there, and how we apply that regression based techniques to understand that particular thing over here, right? Now, there are largely two things that we are interested in. One is what we call as the trend, and the other one is seasonality, right? Now, trend, as was showcased in the previous video that I had posted on Google Classroom, trend is something that tells us on average something is increasing or decreasing with time, right? Uh, as if we take examples of simple things, we can say that on average population can increase over time, right? We can also say that on average, the Nifty 50, which is the index for the National Stock Exchange of the 50 high market cap firms, have increased over time. Now I can simply show you that particular value. So let's say, for example, Nifty 50 is what we want to see. We can see that on a single day, we can see that it has gone down. But if I say, take a 5-year window, started from 10,000 and went over here, if I actually try to look at this, on average, it has increased. In fact, from whenever, if you want to look at January 1999 till now, it almost now looks like that it has increased. It almost now looks like a straight line, except for minor blips, which has happened, one during the recession, probably one during COVID and other things, right? So this is what I mean by a trend. Now, we can also say that something that is naturally decreasing over time, that is what I would call as a downward trend, right? We can say that the total natural resources that we have is in general decreasing with time. That is what trend is. We also discussed what seasonality is. I gave you examples. We discussed about the DOW index. Said that as there are some patterns which keep repeating, that is what seasonality is all about. Now, trend appears something like this. When we actually looked at that Nifty 50 thing, we saw that if I actually draw a line and over time, if I look at any particular thing, let's say, for example, demand, it would probably increase like this. And this is what I would call as a increasing trend. Now, please note that I am only saying that it is increasing on average. It is not only increasing, it is also decreasing with time, right? On the other hand, if we are saying that we have a downward trend, then it would be something like this, right? So this is what I would call as a downward trend, right? So we are only looking at on average whether it has increased with time or not. Now, how do I identify this in terms of regression, right? So how do I do that? First of all, let's look at a visual confirmation that whenever we look at the graph, is it actually increasing or decreasing? I've taken an example of a data over here, which is being collected for 2 years from January 1st to December, and we are trying to use that, right? Let's say, for example, I want to do that. Now, I'll try to simply kind of plot this and see how it looks like. Seems to, I don't know from the directly from this particular line, but on average, it's this value is at 300, this value is at 400, 500. Looks like it is increasing, right? How do I identify that? What I can do is I can actually add a trend line, and this is something that you must have done in business for business statistics as well. Now, the good part with Excel is that you can even see the equation of this particular line. That is, what is this R square and what is the equation of the line over here, right? So we can also do that. What is this? This is regarding this particular line, right? So, yeah, so this is the equation. How did we get this particular equation? What is this x? Now, x here in a trend setting always happens to be the serial number which is representing all this data. Serial number is just nothing but 1, 2, 3, 4, all these values being represented over here. So it is not the January, December values that we are going to look at. It is just merely a serial number. Now, as you will see, we will identify that the equation that we have, we are going to identify from this particular data using regression. Just look at how I am going to get that. So now I am creating a serial number variable, which is 1, 2. So 1, 2, 3, 4, and so on. And I will use this as my equation. So as my independent variable. What will happen over here? What would be the equation? Demand is my dependent variable. So on the right hand side, I will have b naught, which is my intercept, plus b1, which is my slope, multiplied by, as we would have seen in our diagram as well, p happens to be our trend, right? And this trend that I'm talking about is going to be represented by this serial number, right? Let's see how it looks like. So I'm going to go, as you know, how to run a regression. I'm going to use data analysis. And in data analysis, I'm going to pick up a regression. Now, what I'm going to use is my input y range is going to be my demand values. And my input x range happens to be my serial number values, right? So I've selected all this. As you know, I have also selected the labels. So I'm going to select these labels. And I am going to try to see what is the output. So we can focus and try to build this. Let me copy and paste this in the same place that we have that. Okay. Right. So what is the equation over here? As you can see, 349.63 plus 4.6826x. Let's see if we have got the same thing. 349.634. Here they've said 63 plus 4.682. 4.6826, exactly the same equation, right? So intercept is intercept, and the coefficient 4.862 multiplied by x. X happens to be our serial number over here. Now, how do I identify something is an increasing trend or a decreasing trend? Look at the sign of this particular thing. If this data happens to be negative, if this data happens to be, or if this serial number happens to be, or the coefficient of this serial number happens to be negative, that means that your actual data is going down like this, right? If it is positive, on the other hand, it is going up like this, right? So that is what this particular the coefficient of this particular value is actually going to tell you. So if this coefficient happens to be positive, then it is an increasing trend. If it is going down, then it is a decreasing trend. Okay. This is with respect to the trend aspect. We said that seasonality also can be identified using this. Now, in the case of Marriott Rooms forecasting, we were given the date of the week index. Not every data will give you that particular thing. Sometimes you have to figure that out. Now, over here, it seems to be that the data have taken a further long data set over here, which is basically for 7 years, and the demand happens to be like this. On the first look, when I try to plot this particular thing, I don't know whether there is any seasonality, but there seems to be some peaks and troughs, which makes me wonder whether there is any pattern in this. Now, there is a particular concept in seasonality. In this particular example, I'm only going seasonality. I'm only going to focus on the seasonality. I'm not going to focus on the trend part. So in seasonality, there is this concept called as periodicity. And what is this periodicity? Periodicity is after how many time periods is your pattern repeating. If your pattern is repeating after every, let's say, 1 week, the periodicity, and you are collecting data every day, the periodicity happens to be 7. If your patterns are repeating every 12 months and you have collected, or 1 year, you've collected the data on every month, then your periodicity is 12. If your data is, the pattern is repeating after every 4 quarters and you have collected data in quarters, then the periodicity becomes 4, right? So this is how you are going to apply this concept of periodicity. Now, in this particular case, I'm making an assumption that my pattern of demand is going to repeat after every 12 months because it's given in year wise. So this becomes like my pattern, right? Or my periodicity now becomes 12. Now, how do I appreciate or kind of implement this particular thing from the point of view of regression, right? Now, in regression, we have this particular concept called as dummy variables, which you had mentioned that you have studied as part of OR. Now, dummy variables are nothing but variables which can take only values of 0 or 1. Now, for me to understand what these dummy variables are and how do I apply them in regression, we need to understand what is the use of these dummy variables. Now, if you look at this, all I have is the demand values. I don't have any other independent variables. Now, we know for sure that if we want to run a regression, we need to have both dependent variables and independent variables. Even in the case when we were looking at the trend, we did not have any independent variables. We only had demand, but we had naturally created this serial number, which was representing time, and that became our independent variable. Now, something like that needs to happen over here. Now, we said that we are in seasonality, we are interested in patterns repeating themselves. So what we are going to do is we are interested in this periodicity being represented over here. Now, we said because I'm assuming that the pattern is going to repeat after every 12 months, I'm going to assume that each of these particular variables that I have, or each of these particular month that I have, I'm going to take them as one category. And I am assuming that every January, the value that I see over here after every January seems to be closer to that 350, 330 mark, right? That is what I am assuming. It may not be the same, but I'm just assuming that this is the pattern that is following. So I would want to see and represent this periodicity that happens to be 12 over here. That is, after every 12 periods, the demand is repeating itself, and I want to kind of represent that in my regression. Now, the way to represent that is I want to represent the month, each of these months in the regression output. But these months are as characters. So this I am going to consider as like a kind of a variable now. How do I do that? What I'll now do is I will create one variable each for every month, right? Let's make this as January, February, March, April, May, June, July, August, September, October, November, and December. Now, what I am going to do over here is I am going to represent this as, let me put this as Jan, Feb, so you can understand this. Right? All right, so this is how we are going to represent our months. Now, how am I going to use this concept of dummy variables over here? The way I'm going to represent that is, if it is the month of January, in this particular column, only if this particular month, if this particular row is corresponding to January month, I will put this value as 1. If not, I will keep this as 0. Now, how do I do that particular thing? I can actually do that. Maybe over here it is written as year 1 Jan, year 1 Feb, and so on. So if you remember in our Marriott rooms forecasting, we have the date of the week indicator 1, 2, 3, 4, 5. So let me use the same concept over here. What I'll do is I'll say month of the year index. Now, month of the year index, I'm going to represent by 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So this is going to be 10, 11, 12, right? So 12 happens to be December. Now what I'm going to do is I'm going to just repeat this, right? So for every year, I'm going to have same period, right? Now, how do I represent whether this is Jan or not? If this value, if this particular value happens to be 1, then I will say this is 1, if not 0, right? And if I just kind of click on this particular thing or drag this formula, you will see that only when this particular row is corresponding to January, the value in this particular column happens to be 1, right? Now, this particular variable that I've created is called as a dummy variable. Why? Because it is only taking values of 1 or 0. Now, when is it taking value of 1? When this particular row corresponds to January. The same way, this value is going to take value of 1 when it corresponds to January, and so on. All other times, it is going to take 0. By the same logic, what am I going to write as a formula over here for February? This is going to be nothing but if this value happens to be 2, take 1 if not 0. Now, please note that this particular variable is corresponding to February. So you will see that this follows the pattern 0, 1, all zeros, again 0, 1, all zeros, and so on, right? You see that this is 0, this is 1, and so on, right? Now, what can I do? Now, what I'll do is over here, again, this will be what? If this particular value, what is the number that corresponds to March? It is 3. So this will be 3, 1 comes 0, right? Like that, I can create all these values. This is equal to 4, 1, 0, and so on. This is corresponding to 5. So let me make these values and then we'll go into the regression. Okay. Now I'm trying to prepare this particular, copied that particular formula and I'm changing it for all these values so that I can quickly just click on these. Now you can see that it forms a beautiful diagonal pattern over here where all these values, if you can see that this is like a unit matrix, right? Where 1 is there only on the diagonal element and all other values are zeros. This is exactly like that. Now, I have a variable that is representing every single month over here, right? Now, if you look at it, I want to use these particular variables that I have created, which is representing January, February, March, April, up till December over here. Now, these values will go into my regression equation, where my demand will be my dependent variable. All these values will become my independent variables, right? So this is basically the concept of dummy variables. I can use all of this, but there is a policy that we follow in general in regression, especially when we are using dummy variables. that if there are 12 categories, then we use only 11 of the variables, right? Any 11 of these 12. As you can see there, January to December, 12 variables that I've created. Out of these, you choose any 11. Now, the logic behind this particular thing is that the sum of all of these, any particular row, if you look at it, the sum of all of this will be equal to 1, right? That means if I know 11 of them, let's say, for example, I know 11 of them, I automatically know what the other one is because the sum of all of them is equal to 1. So the logic or the policy that we are going to follow for dummy variables is if there are 12 categories, here there are 12 categories because there are 12 months. We are going to use 11 variables. Similarly, imagine if we have 7 categories, that is each day of the week, we are only going to choose 6 variables out of them. If we have 4 categories corresponding to 4 quarters, we are only going to choose 3 quarters. Now, what will be the other quarter? How will I get that particular value? When I show you the output, you will understand that. So to make sure that we look at this, let's run the regression and let's try to understand the output. Okay, so I'm going to select the regression. Here, this demand value is my dependent variable, and my independent variable is going to be, as I said, I have 12 variables. I'm going to select only 11. In fact, you can even select all the 12. Automatically, Excel will give you an error in the output. So that will take care of that. But just for argument's sake, I'm only taking 11. You can try with selecting all the 12 and see what will happen. Right? So let me look at the output over here. So as we generally do, we say that we look at the significance F value, whether this particular regression is significant or not. This value happens to be greater than 0.05. In fact, it's very, very high. So I don't have any confidence in this particular regression output. So that's okay. I'm not really worried about it right now. But what should I do and how do I write this particular equation? For now, let's forget that this particular thing exists, right? Or R square is actually low, all those things. Let's forget that for a moment, okay? Let's assume that all of this happens to be significant. That is, the p-values all happens to be significant, and this is also significant. And we get an equation like this, okay? What does this particular thing mean? So let's try to apply this. Let me write that equation so that you will understand it. So this is how the equation is. And these are the values, right? So my equation now will become 498.14 minus 94.28 Jan minus 50.85 Feb minus 77.28 March minus 94.14 April minus 71.14 May minus 46.14 June minus 78.14 July minus 71 September or 71.4 August minus 71 September minus 54.42 October minus 77.14 November, right? So this is the equation that I have. Now, how do I get so this is my demand. This is my forecasted demand, right? So forecasted demand I have got from this particular equation. Now, what does this particular thing mean? How do I interpret the results? So we said that for every 1 unit increase in this will lead to minus 94.28 decrease in demand. That is how we interpreted the results in the past class, right? So we can over here, we can say that for every one, so this is my equation, right? So 349.63 plus 4.6826x, that is on average for every 1 month that you are increasing, every 1 month, your demand is increasing by 4.68 units. That is what you can interpret from this. But how do you interpret this particular thing? That is your dummy variable thing. Now, as we know, all variables from January till November can only take values of 0 and 1. So let's say, for example, in this particular month, the month happens to be January. The month happens to be January, and if the month happens to be January, I know that only Jan variable can take 1. All other things will take 0, right? So for example, I want to predict what is the demand in the month of January, right? So I know that this value will be 1 and all the other values over here will be zeros, right? So just substitute values over here. Demand will become equal to 498.14 minus 94.28 into what is Jan value? Jan value is 1 minus all the other things are just going to be 0, right? So this is what I'm going to get minus. So if you take minus 50.85 into 0 minus 77.28 into 0 and so on and so forth, right? And so on and so forth. So just to make this calculated, so I'm just going to do this. So this happens to be 403.86. Now, the same way I can calculate for Feb. In Feb, this value will be 0, this value will be 1, and so on. All others will be 0. The same can happen for March and so on. Now, if I have to calculate, let's say, for example, for December. Now, December is not there in this equation. If the month happens to be December, what will happen to all of these? All Jan to November values will be 0. So what is the only thing that will be left for December? It will be 498.14 minus 0, minus 0, minus 0, minus 0, and so on, right? So what will be this particular thing? The 498.14. Now, the other way to interpret this particular thing is that this intercept value that you see over here is nothing but the value that is representing the variable that you did not pick. That is the nth category that we did not pick because we were always picking n minus 1 variables. So policy to remember over here, few things to remember over here. Whenever you are using dummy variables, when will you use dummy variables? When we have categorical data. That is like this. Whenever there is seasonality, I would represent it like this. First, I'll identify the periodicity. With periodicity, I will identify the categories, how many categories of data and what pattern is repeating after what values. Based on the number of categories, create dummy variables for all of them, right? Now, dummy variables will only take 1 or 0. 1 if that particular value belongs to that particular category, 0 if it is not, right? Then when you are running your regression, if there are n such categories, you are going to have n minus 1 variables, right? N minus 1 variables in your regression. Once you have run that, focus on the coefficients, write your equation like this. If you have to calculate the data or the average forecasted demand for that particular month, substitute the value corresponding to 1 in that particular month and zeros everywhere else. Or depending upon whatever thing that you look at, quarters, weeks, days, all those things, substitute that particular value for 1 for that particular category and 0 for others. Now that particular category, that nth category, which we are not representing as a variable in our regression equation, that will be generally represented by your intercept. So this is the concept of dummy variables, and this is how you run your regression to predict the forecast or forecast the demand in the case of seasonality. All right.